Today we're going to talk about Sohcahtoa. And no, I didn't say that wrong. What that is actually a way to remember trigonometry definitions. So if you cut to my screen, I can show you today how Sohcahtoa can help you with some geometry and trigonometry. So first, let's talk about, actually, let me introduce you to this little guy here before I confuse you too much. This guy here is called theta. And theta is a variable, just like x. And we use theta to represent missing angles. So you're going to see that in the trig definitions in a minute, and I wanted to make sure you knew so I didn't confuse you too much. So trigonometry is based on, in fact, let's look at the word, trigonometry. All right, trigonometry is based on the study of triangles. So that's really what trigonometry is based on, is the study of triangles. So trigo meaning triangles and ometry meaning measurements. So trigonometry is based on triangles. So there are three basic trigonometry functions: sine, cosine, and tangent. Sine is always categorized, or defined as, we should say, as the sine of any angle is the ratio of the opposite side of a triangle to the hypotenuse side of a triangle. So let's talk about this really quick before I give you some more definitions that don't make sense. So on a right triangle, we have three different sides, depending on which angle you're looking at. The hypotenuse is always our longest side. So we are going to highlight, this is called the hypotenuse. And you may remember that from your studies in geometry, maybe Pythagorean theorem, but the hypotenuse is always the longest side, and it's always the one that is opposite of the 90-degree angle. So if you find your 90-degree angle, it's always the one right across from that. So that is our hypotenuse. Our opposite side kind of depends on which angle we're looking at. For right now, we're going to say that we're looking at this angle right here. We'll call it theta. The opposite side will be if you take from that angle theta and you follow it across to the opposite side, it'll be the side kind of across from that. So our opposite side in this case is this one. Now that would change depending on what angle I was looking at. If I was looking at the angle on the top up here, so if I was looking at this angle, then the opposite side would be the one on the bottom here, right here. So it depends on which angle you're looking at. So that's one thing that can be very confusing with this is, well, which side is which? Well, it always depends on the angle you're looking at. So let's go back to orienting it the way that I originally oriented it. So we'll say that this side is, this is our theta, and then our side over here across from it is our opposite side. That leaves kind of the third side, which is the adjacent side. And think about what the word adjacent means. The word adjacent means right next to. And you can kind of see that this side is right next to theta. So that is the adjacent side of this triangle when we are talking about this angle theta here. Now again, that switches. If my angle were up top and I was talking about this one up here, then my opposite and adjacent side would switch. So back to our trig definitions. We said that the definition of sine, and the abbreviation of sine is sin. Don't call it sin. Your teacher will kind of in their head laugh at you and think that you don't know what you're talking about. It's called sine. And that is the ratio of the opposite side over the ratio of the over the hypotenuse. It's the ratio of the two. The definition of cosine is going to be and we abbreviate it with COS, don't call it cos, because your teacher again will laugh at you, maybe not out loud. But cosine of any angle is going to be the ratio of the adjacent side over the hypotenuse. And then the last one is tangent, and tangent of any angle is the ratio of the opposite side over the adjacent side. So, where all of these, the Sohcahtoa comes from is, you can kind of probably see here, is so, S-O-H, is talking about the sine definition, opposite over hypotenuse. Ka, C-A-H, is talking about the definition of the cosine function, adjacent over hypotenuse. And tangent is talking about the opposite over the adjacent hypotenuse, the opposite over adjacent ratio. So Sohcahtoa is a way that you can remember the definitions of your three basic trig functions. Now here's how we can use it. We're going to talk about a very quick example on how to use these definitions to help you find missing side lengths or missing angles of triangles. Now, it should be noted that this only works for right triangles. There are other ways that you can find missing side lengths and angles of triangles that are not right triangles, but this only works for right triangles. So what we do with this, and I'm going to make up a little example here with some missing side lengths. All right, so let's just say we had, we know that the angle, so we already know our 90-degree angle, but we know that this angle here is 53 degrees, and we know that this side is 45 units, and we need to know what that side is, what that hypotenuse is. So what we do to use these definitions is we think about which two sides in relation to our angle are we using. So if you think about, if this is our angle, this K is going to be our hypotenuse, so H, and then this side here, so what I do, this is how I do it anyways, is I'll follow this across, and I know that over here, this must be my opposite side, so by process of elimination, this must be my adjacent side. Now this is a good way to start any of these problems, is by writing out which side is which. So I now have my hypotenuse and adjacent that I'm going to be working with based on the angle that I know. And if you look back over to our definitions, adjacent and hypotenuse is our cosine. So that means we're going to write a cosine equation. We're going to say cosine of our angle, if we know it, of 53 degrees, is going to be equal to, and we go back to our definition, it's going to be the adjacent side, which is 45 units, over our hypotenuse. And this is the one that we don't know, which is K. So now what we've done is we've created an equation that just has one variable. We just have to get it by itself, and then we'll know what our missing side length is. So one of the issues with this equation is that we have K or a variable in the denominator, so we want to initially start by getting it out. So if you think of this as 45 divided by K, we can multiply both sides by K to get it out of the denominator. It eliminates it on the right side of the equation. So rewriting our equation, we now have K times cosine of 53 degrees equals 45. Now, at this point, I've seen a lot of students get stuck, and it's because this trigonometry definition gets confusing for them. But what you have to remember is that this cosine of 53 degrees, it's just some number. It's the ratio of the adjacent over the hypotenuse side. It's the ratio of this triangle. So it's just some number. So this is like if I had K times some number. To undo it, to isolate K, we're going to divide. So I'm going to divide both sides of my equation by cosine of 53 degrees, because again, it's just some number. And what that then does is it isolates K. So eliminates our cosine on this side, K is now by itself. At this point, this part here, you're gonna need to type into your calculator. Now there's one big thing that you need to remember is check your mode in your calculator. So how you do this is you go on a graphing calculator, which I'm sure a lot of you guys use in school. You go to the mode button, which is right next to, I hope that you can kind of see that, it's right next to the second key. And what you want to do is you want to make sure that the third row down, and hopefully we can get a graphic on this and show you guys. The third row down, there's a choice between radian and degree. Radians is another way that we can measure angles. However, in this case, we're still using degrees, so we want to make sure that's highlighted. So we go to the third row down, make sure that degree mode is highlighted, and then we quit out of that. And again, at this point then, we can now go ahead and type into our calculator 45 divided by the cosine of 53 degrees. And what we get is 74.77. So that means, back up to our triangle, is that our hypotenuse, or K, is going to be 74.77 units based on this. So there's an example of a missing side length. I'm going to show you really quickly an example of a missing angle, and hopefully that will kind of cover what these trig definitions, just at least part of what these trig definitions can be used for. So I'm going to go back to my triangle and I'm going to relabel it because we're now going to look at a different triangle and a different problem. So, oh, threw my pen. So let's get rid of all of this. All right, so here's a missing angle problem, and what we'll do is we'll call this angle theta because it's missing. We don't know what it is, and then we're going to call this side length 10, and we're going to call this side length 12. Now, obviously, it's not to scale because you could kind of see how my 10 side length is a little bit longer than my 12. But that's okay, that's not the point. So again, we're going to need to start by figuring out which trig function we're going to use, sine, cosine, or tangent. So the way we do that is we, again, think about what angle we're using and then think about what the sides are that we know in relation to that angle. So here's our angle theta, and if we follow it across, you can say, oh, that is our opposite side. So we're going to label it opposite. We also know that it's not the hypotenuse because this is our hypotenuse. Hypotenuse doesn't change. It's our longest side. So that this 12 side here has to be the adjacent side, the one right next to the angle, which makes sense. So we are working with opposite and adjacent. Opposite, O, adjacent, A. So back to our definitions, we look at which one deals with O and A. And that would be our tangent. So we're going to write a tangent equation. We're going to say tangent of theta, and this time we don't know theta. We don't know what it is, so we are just going to say theta is equal to the opposite over adjacent. So 10, which is our opposite side, and adjacent, which is 12. So now we have to isolate our variable. And what I would say some students want to do is they want to divide by tangent, or they want to divide by tan. Doesn't work. This is all one function. So the only way at this point to find it is to do the inverse function, which you may have learned about already, which means that our input and our output switch. So what that does is that creates tangent, and then this little -1 here that just means the inverse. And now I'm switching my output from my input. 10 over 12 equals theta. And all in one step, we isolated our variable. We got theta by itself. We just have to calculate. It's just like our last problem where this is just some number. And there is actually a button on your calculator for inverse trig functions as well. So you can push, if you look at the tangent button, right above it in blue it says tan -1, which is the inverse tangent button. We're going to hit second inverse tangent and do 10 over 12, 10 divided by 12, close our parentheses, And we get that theta is equal to 39.8. Now what I like to do with angles is that point, like tenths of an angle, don't really make much of a difference, so I round up to the nearest angle is what I do. So this is 40 degrees is this angle. Also, I should have said this, be sure to check your mode. Get in the habit of doing that. Make sure it is in degree mode in your calculator. That's really important because it'll give you completely incorrect answers if you don't do that. So there's an example, just to kind of sum up what we just did. There's an example how we can use the definitions of the three basic trig functions, sine, cosine, and tangent, to be able to help us find missing side lengths and missing angles of right triangles. And the way to remember that is with that silly word that I said at the beginning, Sohcahtoa. Thanks for watching this episode of Tutor This. As always, if you have questions or suggestions for future episodes, leave them in the comments below. Remember to click the like button below, and if you enjoyed this video and want to see more like it, hit subscribe.